Connect it to a 6-volt DC motor and see how it performs. Look at that. It's running smoothly. Supercapacitors are truly fascinating. If you found this interesting, don't forget to like, share, and drop your thoughts in the comments. This is a 12-volt gear motor that I extracted from a 12-volt air cooler. This type of motor is specifically designed for high torque and efficient performance, making it perfect for applications where controlled and powerful movement is required. Now let's carefully remove its cover and explore its internal components to see how it operates. As we open it up, wow, amazing. You can see an intricate system of multiple gears inside, rotating smoothly. These gears help in reducing speed while increasing torque, allowing the motor to drive components like oscillating louvers in an air cooler. If you enjoyed this teardown, make sure to like, share, and comment your thoughts. What other motors or gadgets should I explore next? Let me know in the comments. Hey everyone! Today I built a simple electric project using a 3.7-volt battery, a reed switch, a DC gear motor, and a light bulb. The bulb is wired in series with the reed switch, and the motor is powered by the same battery through a mini switch. I attached a small wooden arm to the motor shaft with a tiny magnet at one end. When the motor spins, the magnet moves closer to the reed switch, turning the bulb on. As it moves away, the bulb turns off, creating a cool automatic flashing effect. Let me know what you think in the comments. Today, in this exciting video, I'm testing the power of this high-speed drone motor to see if it has enough thrust to lift this dinosaur toy into the air. This motor spins at incredible speeds, generating strong airflow, just like the ones used in actual drones. Will this tiny but powerful motor be able to lift it? Watch till the end to see the results, and don't forget to like, share, and comment with your thoughts.
Here's an amazing LED solar outdoor light with a motion sensor. It features 3 lighting modes, making it perfect for your garage, garden, street, shed, or yard. This light is waterproof and built for all weather conditions, ensuring reliable performance outdoors. The motion sensor detects movement and automatically turns on, providing added security and convenience. Plus, with its solar-powered design, there's no need for wiring. Just set it up and let the sun do the work. I'll be testing this light in a detailed video soon, so stay tuned for that. But if you're interested in getting one right now, click the products button here to check it out. Make sure to like, share, and subscribe for more cool gadget showcases.
Today I've built a powerful mini DC fan using a high-speed DC motor typically found in drones and a supercapacitor as the power source. Drone motors are known for their impressive speed and efficiency, making this fan surprisingly strong for its size. The supercapacitor I've used can store and release energy much faster than a regular battery, which gives the fan a quick and powerful start. Now let's test it out. This is an LED. Now let's connect it to a 3.7-volt battery through a 100-ohm resistor. As we complete the circuit, the LED lights up, indicating that the current is flowing in the correct direction. Now let's reverse the polarity by swapping the battery connections. Since LEDs are diodes, they block current when reverse biased, so the LED does not light up. To solve this issue and allow the LED to work regardless of polarity, we'll use a bridge rectifier. Now we reconnect the battery and the LED lights up. If we swap the battery terminals again, the LED still works, demonstrating how the bridge rectifier automatically corrects the polarity. A farad is the unit of capacitance in electronics, named after Michael Faraday. Capacitance is the ability of a component to store electrical charge. A capacitor with a capacitance of 1 farad can store 1 coulomb of charge when 1 volt is applied across its terminals. 1 farad equals 1 million microfarads. This capacitor rated 500 farad, which is equal to 500 million microfarad, which is a very big value. For complete details, visit sciencequizbook.com. Today I have used four 1N4007 diodes to build a full-wave bridge rectifier, not for AC to DC conversion, but to change polarity. Let's test it. I connected a DC power source with the rectifier and swapped the input polarity. Normally, reversing the polarity could damage sensitive components, but with this circuit, the output polarity remains the same no matter how I connect the input. This technique is super useful for protecting circuits from reverse polarity connections. What should I test next? Let me know in the comments. And don't forget to like, share, and subscribe for more cool experiments. Hey friends, today I've built a cool little gadget, a super capacitor-powered mini-hand fan. I call it the Turbo Breeze fan. This tiny fan runs without a traditional battery. I've used a simple setup, a DC motor, a supercapacitor, and a switch. Now let's charge the supercapacitor with a 3.7-volt battery for a few seconds. Okay, here we go. I'm flipping the switch, and look at that. It's spinning effortlessly. But here's the twist. How can a fan run with just a few seconds of charging? What's the secret behind the supercapacitor's power? Can you guess the science behind it? Let me know in the comments. This is a 12-volt LED. Let's try to light it up using a 3.7-volt battery. But wait, it's not working. As expected, the voltage is too low. Now let's try something different. I've connected two DC motors using pulleys and a rubber band, so when one spins, it drives the other. Let's see what happens next. Watch carefully. I'm going to connect the same 12-volt LED to the terminals of one DC motor, and now I'll connect the 3.7-volt battery to the other DC motor. Still nothing. But what if we switch the polarity? Look at that. The LED is glowing. But how? Just a moment ago, the same battery couldn't light it up. Now with this setup, it works perfectly. What just happened? Can you figure it out? Let me know your thoughts in the comments. This is a DC gear motor. When I connect it to a battery, it rotates in the clockwise direction. If I swap the positive and negative wires, the motor reverses its direction and rotates counterclockwise. This happens because a DC motor's rotation depends on the polarity of the power supply. However, in some applications, we may need the motor to always rotate in the same direction, regardless of how the power connections are made. To achieve this, we can use a bridge rectifier. A bridge rectifier ensures that the polarity reaching the motor remains consistent, even if we change the input connections. Now, I have connected a bridge rectifier to this motor. As you can see, even when I swap the battery terminals, the motor continues to rotate in the same clockwise direction. This setup is useful in circuits where maintaining a fixed direction of rotation is crucial. This is a mini DC gear motor, and today I'm going to experiment with it to see how much electricity it can generate when I manually spin its shaft. First, I'll attach this chunk to the shaft to get a better grip for spinning. Next, I'll connect the positive and negative probes of my multimeter to the motor's terminals. Now let's spin it and see the results. As you can see, the motor is generating electricity, but the voltage is showing as negative because I connected the wires in reverse. Let's correct that. Now, with the correct polarity, you can clearly see the voltage output from this DC gear motor. If you found this experiment interesting, don't forget to like this video. Also, comment below with the voltage reading you see and share your thoughts on this experiment. Let's discuss. This right here is one of the most powerful supercapacitors you'll come across. It's rated at 2.7 volts and an incredible 500 farads. Yes, 500F. But what does that really mean? To give you an idea, a 500F supercapacitor can store a surprisingly large amount of energy compared to smaller capacitors. Farads measure how much electric charge a capacitor can hold, and 500 farads is massive for such a small component. Now let's put it to the test. I'm going to connect this LED to the supercapacitor. Will it light up? And if it does, how long do you think it will stay on with just 2.7 volts? And if you know why 500 farad is such a big deal, drop your answers in the comments below. Something unbelievable just happened. I managed to generate 38 volts from a simple 12-volt motor. Sounds impossible, right? Here's what I did. I mounted two DC motors on a wooden platform. One is a 6-volt motor, and the other is a 12-volt motor. I attached a large pulley to the 6-volt motor and a smaller pulley to the 12-volt motor, connecting them with a rubber band like a belt. Now comes the exciting part. When I powered the 6-volt motor using a 12-volt battery, it started spinning rapidly and drove the 12-volt motor like a mini generator. The result? A shocking 38 volts of DC power. But how did a 12-volt setup produce 38 volts? Can you figure out the science behind this surprising outcome? Share your thoughts in the comments. Today, I have built a simple yet interesting electrical project, a small bell that runs on just 2 AA batteries. It's an easy DIY project that anyone can try at home. Do you have any ideas for improving this setup or want to suggest any modifications? Let me know in the comments. I'd love to hear your thoughts and creative suggestions. This is a Melody integrated circuit, the UTC-UM66T19LK, which is designed to produce a musical tone when powered. I have carefully soldered it to a buzzer, creating a simple yet effective musical alarm system. When I connected a 3.7-volt battery, the circuit immediately started playing a pleasant melody. This small yet powerful IC is commonly used in doorbells, toys, and musical greeting cards, making it a great choice for fun DIY projects. If you enjoyed this video, don't forget to like, share, and leave a comment with your thoughts or any improvements you'd suggest.
This is a small supercapacitor, but have you ever wondered if it has enough stored energy to power a light bulb? Let's put it to the test. First, I'll fully charge the supercapacitor to store as much energy as possible. Once it's ready, we'll connect it to the bulb and see what happens. Now for the exciting part, and look at that. The bulb lights up beautifully. It's amazing how this tiny component can hold and release energy so effectively. If you found this experiment interesting, don't forget to like, share, and leave a comment with your thoughts.
Today, I have built a working model of a water level indicator designed to monitor the water level in a tank. To demonstrate how it works, I will test it using a simple water glass instead of a large tank. This model is designed to show how water levels can be easily monitored using LED indicators. Now let's test it. I slowly start pouring water into the glass, and as the water level rises, something amazing happens. The LEDs begin to light up one by one, from the bottom to the top. This visually represents the increasing water level, just like how a real water tank level indicator works. Don't forget to like, share, and comment if you enjoyed this experiment. In this experiment, I attached a heavy wheel to a DC motor and powered it up. After reaching high speed, I disconnected the power and connected an LED to the motor's terminals, and the LED lit up. Can you guess why this happens? Share your thoughts in the comments. This is a syringe, and today I'm going to turn it into a glowing light experiment. First, I'll carefully remove the protective cover. Next, I'll take a vibrant 7-color LED and insert it right into the cover, fitting it perfectly inside. Now comes the exciting part. I'll connect the LED to a 3-volt coin battery, instantly bringing it to life. But the real magic happens when the lights go off. The glowing LED inside the cover creates an almost hypnotic neon effect. If you enjoyed this experiment, don't forget to like, share, and comment. What should I try next? Hi friends, today I'm excited to share a fun and creative project, a DIY air-powered mini car. This project uses a few simple components: a 9-volt battery to power the motor, a 9-volt battery connector to link the battery to the motor, a DC motor to drive the propeller, a set of toy wheels for movement, and a propeller to generate thrust. This mini car is an excellent way to combine creativity with basic engineering principles. It's simple to make, affordable, and a lot of fun to play with. Today I picked up these DC motors from my local market for some exciting upcoming projects. Before diving in, I'll check online to see if I can find the exact models. If I do, I'll add it to the product list. Now let's put them to the test by connecting a 9-volt battery and seeing how they perform. As you can see, it works smoothly, delivering a nice and steady spin. If you enjoy this video, don't forget to like, share, and drop your thoughts in the comments. Hi friends, today I have built an exciting air-powered car. I used a supercapacitor as the power source, a DC motor to spin a fan, and toy wheels to make it move. When the supercapacitor is charged, it powers the motor, which drives the fan to push air backward, propelling the car forward. This project is a fun way to explore how air thrust and stored energy create motion. Let me know your thoughts in the comments. Don't forget to like and share. This is a 2.7 volt 10 farad supercapacitor. Today I'm going to use it to power this DIY bell. But will it work? Let's find